So we do, finally, also the percentiles. Percentiles is a bit like the mean, a bit like the median. Just with the median, just to say that right away, like this. The 50% percentile, I'm going to define to you more thoroughly what a percentile is. That is the same as the median. And let me put some more words on this. What does it mean to be a median? Well, personally, I like sometimes to participate in different races. You go to Imitation a little bit or something else, running with all the other stupid 35,000 stupid guys running around, trying to avoid what cannot be avoided anyway, but trying to at least, when you are participating in such a race and you have realized and convinced your family and your daughters that no, I did not win this time, no, I didn't win this time either, so I'm not going to win Imitation a little bit. I know that. What I'm interested in is how good am I relative to the other people. That's my way of, and if I'm right in the middle, I have 18,000 in front of me and I have 18,000 after me, I'm a median. I have 50% above, 50% below. I'm a 50% percentile, right? That may be a pretty good result. I'm a 50% guy. Well, you could have higher ambitions. You could say, I want to be a 10% guy. I want to be a 10% percentile. I want to be in a position on these times, on these numbers, where I have only 10% above me and 90% below me. Same things, same way of measuring people are used by different testing systems. If you take the TOEFL, TOEFL test for a test of English as a foreign language, if you're Danish and you want to go abroad, you might be taking this test. You will be told typically we're pretty good in Denmark, so we may be 80, 90, or 95% guy or person in such a distribution of many, many, many results across the world of non-English speaking people. That is a percentile. That is the position in the data that divides, for instance, we have special names for certain percentiles. For instance, the 25% percentile we call the lower quartile. So this is the lower quartiles. We put the data into 4 positions and we find the point that have 25% to one side and the 75% to the other side. And vice versa with the 75%. That's the upper quartile. Maybe to be strictly speaking, there is a matter of definition whether we call it one or the other. I should say if I'm ambitious, I should be a 90% guy, having 90% below me and only 10% above me. But you can change the definition, change the end of this if you want. Anyway, how to find a percentile in practice? There is a rule for that. Let me use this rule on the data. Again, let me take it. Let me do it here. Percentile. Let's use the n equals 5 sample from before. 73, 74, help me. 75, 80, 93. I skipped all the hundreds. It doesn't matter for the point I want to make. Now, it can be a bit awkward or a bit funny with such low numbers. I mean, if you have 30,000 people running Imitation a little bit, if you want to go for let's say we want to go for the lower quartile. The lower quartile. Q1 is the name for that. That is, you could say we have kind of a percentage corresponding to 25%. That's sort of then we would, out of 35,000 runners, we would take what is 35% of these 36,000 and say that would be 9,000. Then we would take number 9,000 from below. Then we would have 1/4 below, and we would have 3/4 above. Right? Now, how do we take 1/4 of a general number? We always compute n NP. That's the general rule for finding a pth percentile when we have n observations. We compute NP. In this case, it's just a small number, but the rule can be applied. It's a clear rule. There are various different definitions here. R may actually produce slightly different definitions, but just the book has a nice and well-defined rule, and that is a valid rule for us to use. The thing is, there are two options with the median. Either this number is a whole number, an integer, or it's not, right? When it's not an integer, the rule is to take the next one. So in this case, it would be the second from the bottom. So whenever it's not an integer, and this is the same rule as for the median, actually. It works with my definition of the median. If it doesn't give you an integer, you go up to the next one. So in this case, the lower quartile would be 174, just to avoid confusion for people looking at it afterwards. Let me keep the ones anyway. Had we, let me see, we could also have gone for the 20% percentile, right? The 20% percentile. Then NP would be 1, 5 times 0.2. Now we have the situation with an integer. When we have an integer, the rule is, as for the median, to take this one plus the next one, average. That's the 20% percentile. This is where R may have slightly different, you may weigh them differently. But anyway, this is one of the valid rules to find such a quartile. Or percentile, sorry, I should say. Okay. There are some plottings here also. Importantly, looking at numbers is not just computing summary statistics. So we are at a part in the course where we start by, let's start looking at the numbers. I've told you statistics is much more than that, but we shouldn't stop looking at the numbers. Right? Looking at the numbers can be done by summary statistics. It can be done by different plottings, as you will have used in reports in your school life for many, many years already. All of these plots are probably familiar to you in one way or the other. If you look up the newspaper, we'll see versions of these plots every day. It's a part of the math education that you get used to looking at such plots. It's very easy in Excel or in R to make those standard plots. One plot I would like to emphasize is the box plot. The box plot is formally a part of the syllabus. You'll see, you can read about it in the book. The pages are given explicitly. The box plot, we're going to have a look at it soon, but let me just illustrate this. It's a plot like this that gives you Q1, Q3. It gives you the max. It gives you the mean. That's the box plot. So it shows you the lowest, the highest, the box where you have 50% of all data. That's between the 25% percentile and the 75 percentile. You have 50% of the data, and this is also called the IQR, the interquartile range. It's a measure of variability. It's another measure of how much is the data spreading. What is the interval of 50% of my data? What is the interval of 50%? The middle interval of my 50% runners, for instance. What are the running times going from in this middle interval, 50%? And then I keep on forgetting whether the middle one is used as the mean or the median. Mean? Median, good. Because that makes most sense here. Thank you. So the median is in the middle. It's a nice way of looking at data. So let me try to exemplify some of this while I introduce the next point, while I introduce the next George topic of today's lecture.